This talk is called Iterations on a Mandolin. I don't own a mandolin myself, but this could be a close analog. It's a simple box grater, and you would use it in the kitchen to slice things, or maybe to shred things as well. Both of those are useful things in the kitchen. The mandolin you see on the screen is a Japanese mandolin, but the one on the bottom is Italian. So the one on the top gets its name from the strumming action of the instrument. And I like the duality of that. Two tools with the same name, but a different context. So let's mash up some tools and see what happens. Before I get to the kitchen, I'd like you to think of a mud puddle. Maybe there was a moment in your childhood when you jumped in one, or you were making mud pies. So a creative practice has roots maybe in some kind of play. What I noticed is that sediments below the escarpment are collecting particles from those layers of Ordovician rock 400 or 500 million years old. So these are very fine sediments, and they trace lines in the earth. When the water and wind get to work on the sand, things begin to happen, and when insects crawl over them, they also leave trails behind. So I always had an interest in sort of paying attention to those footprints, if you will, of different processes. Some of them are living and some not. So these are journeys that are made by critters or by water streams. We're also making journeys as human beings. If you've ever done any painting, you'll appreciate that a brushstroke is a kind of journey as well. So the surface of a canvas could be compared to a roadway or a trail on which you're walking. So I've been exploring how people move on the surface of the world, and these are snow piles along the road from here to Timmins. Added some contrast for effect. There's a signpost marking the kilometer that's bent out of shape by the snowplow on the top. I appreciate those snow piles at the side of the road. They are a record of the snowplow moving, and of also where we want to go along the roadway. But they're not maybe the focus of our attention. We're more interested in the destination than the journey. I got to thinking that these screens are all 16 by 9, but a panorama often has its own proportion much longer than that. My brother, who lives in Timmins, is a 7-hour drive away. Imagine if the dimension of your screen was 7 hours long. What would that mean? Can I make some mashup of a long stretch of time or a long stretch of space? What might that involve? Here the panoramas don't fit on the screen, so I put them in rows to be able to appreciate the full length. That happened because I was involved in a vocal ensemble. We were singing choral music, and this reminded me of a score. I started showing these, but then they didn't fit in my car, so I needed a new strategy to make it fit, if you will. Making panoramic images led to the creation also of spiral work. So this leads me to my first demo. This was done in Photoshop with JavaScript. Did you know you could do JavaScript in Photoshop? Did you know that Photoshop generates JavaScript for you when you ask it to listen for your actions? You might know there's an actions panel, but there's also such a thing as a script listener that you can enable. Here is a script that is designed for Photoshop. It targets Photoshop. VS Code doesn't recognize that, but Photoshop does. And so most of this I didn't write. Most of it was written by Photoshop. My role here was to orchestrate the pieces. If you look at this code, it's hardly legible, but I know what it does because I recorded it. Here it says make circle. That's what I was trying to do. And that's Photoshop's way of saying, let's make a circle, according to some parameters. So having described that action as a function, I can now orchestrate it at will according to any algorithm that I write. So those are the more human readable parts of this script, where you'll find code comments describing proportions of segments of panoramas that, when stitched together at the appropriate angle, result in a kind of spiral that we saw earlier. Shall we try it out? Okay, in order to make a spiral, I will need to have some kind of panorama to begin with. This is from a couple weeks ago, outside on this very parking lot. This panorama was made not by making multiple photos, but derived from a video. So we'll come back to that. But I would like to show you what Photoshop does when I feed that JavaScript into it. I've saved it here, and you can find it on my GitHub page too, if you like. So how far apart should the rungs of the spiral be? We've added this parameter. I'm going to leave it at the default. And Photoshop is going to take a second to chop this long panorama into pieces. Each piece slightly longer than the one before. That's the logic also that you find if you see a snail shell or other elements in nature that follow patterns. So in algorithms, we can get inspiration from those patterns that we observe and maybe not mimic them exactly, but get some ideas for how we could do things in JavaScript that follow a particular order or arrangement. So Photoshop has done the heavy lifting here, and now those snow piles have been assembled to a spiral. Okay. What I enjoy about this particular part of my process is the surprise when it reveals the progression of the journey from start to end. You might not notice the gradual changes in the landscape as they unfold. But when you can see the entire journey at once, it might open up a different window into seeing what is that experience like? How did it unfold over time? So the way this snow pile was made has a precedent, and what we're looking at is a photo of horses, you might say. Which of the horses won the race? Who crossed the line first? So this is known as Slit Scan photography, and it allows us to decide not what the horses look like, but what was the journey that the horses took. That's a slight difference. We're not seeing a picture of a horse, but the movement of a horse across a particular sliver of space. If we do this in another setting, we might find that the result is somewhat different. Horses move maybe in a uniform linear direction. They have a focus, a goal, the finish line. What about people? People tend to wobble around a little bit more when they walk. So here we have the Osheaga Music Festival in Montreal. Concert goers meander around on this footpath, and the camera is fixed, watching from above on a bridge that spans the footpath. So we're looking at a still from something a little bit longer, and you're welcome to follow this QR code if you like. And I'll set it to scroll automatically. So if I have a video, say 10 minutes worth of footage of people walking by, and I take a pixel, or a row of pixels rather, from each frame, and I stitch them all together, I get a slice of that video, a cross-section, if you will. The people that you see, or rather the journeys of people that you see, follow different paths. If you see a person for a small duration of time, they appear as a blip on the radar. The camera didn't see them for very long, and neither do we map them onto space for very long. But when people hang around and chat for a while, you might see that they've been stretched out to fill a long dimension of this image that transcribes time onto space. So this is not new. I've seen a lot of slit scan work, but I'm intrigued by it because I think it reveals something about the patterns of living, that is that some human element that is coming to the surface. We learn about our own behaviors in, I think, an interesting way. So I was curious what else could be done in this space and what tools might be involved. How could we also celebrate the way that people move? How could we amplify the variation in bodies and in walks of life? In this iteration, the camera is fixed, but now the camera moves and the subject is fixed. So we have the same technique, but it's been flipped around. The video now is the recording of a dash cam. Campbellville Road is a stretch between Highway 6 and Campbellville, I suppose. And I used to traverse that little stretch of road on the way to visit family members. It has its own unique texture. There's shadows of trees. There's sections of road that are double-lined, sections that have dashed lines, sections that have tar to fill in the cracks. There are hills. There are lots of wobbles in the road. But what surprised me was that I was the one wobbling too, with my car in the lane. I was not staying centered in my lane. And so my video revealed the way my car was wobbling back and forth. So this line records not a picture of Campbellville Road, but of a particular journey through that street. And if I had some kind of stabilizer in my car, I could expect that line to be straight. But maybe I don't want it to be straight. Maybe the wobbliness of it is precisely what makes it interesting. So you know how videos are put together. They're made with frames, right? And those are sequential, generally. If you have an MP4, each frame follows the other in a linear fashion. That's how we decided to model time, because it's convenient. You don't want your Netflix show to be all wobbly. You want to see those characters in crisp 4K precision. But we don't have to chop up videos like this. We could do it differently. If I take my mandolin and I slice the cucumber horizontally, this is now analogous to what we're seeing with Slit Scan work. You're seeing a cross-section that's different from what we usually encounter. This could be a costly thing to do. This might take a lot of CPU power. We have to scan through all the frames in the video and extract from them some detail. Whereas the frames as we know them, this is easy. Our codecs are optimized for this. It's very quick to do this. Why is it quick? We can discard the frame as soon as we see it and move on to the next one. We don't need to put the whole thing in memory. We don't need to deal with the whole bulk of it. It's one frame at a time. But to construct something like this computationally is difficult. It can be done in a lot of different ways, a lot of ways to solve that problem. And I was interested in exploring that. I was thinking I could animate those cucumber slices to see what the structure of the cucumber is. So it would no longer be an image, but a series of cross-sections that animate. It might be like this brain MRI scan where we have multiple cross-sections that, when put in sequence, give us a picture of the inside of our heads. So how would I do this with any video? Maybe I want to make multiple slices. I'm not happy with just one. I want to go deeper. So here is a piece of software, the building blocks of a video mandolin, FFmpeg, an open source tool for manipulating videos, transcoding videos, cropping videos, assembling the frames in a new way. So what does this mean? FFmpeg. FF stands for Fast Fourier Transform. This is the math that powers our video codec. So the reason we can have TikTok and YouTube is because of video compression. In the early days of computing, someone discovered the math to take a shortcut. That's what Fast Fourier Transform does. It allows us to speed up the encoding and decoding of signals. And that's really useful when it comes to images and videos, because encoding and decoding them quickly is really important to build any kind of fluid experience. So this is the right tool for processing video. It's going to help me speed up the process. Let's see what we can do with this. Can I take a video and turn it into an image, right? That's the goal. I want to take a slice of time. And I've called this the hot sauce. It took me quite a while to realize that this was possible. Reading through a lot of thick documentation to understand that you could chain these things together. So let's look at an example of this. Here's a butterfly in the fields. I'm not sure exactly. I can't remember where this was, but somewhere in Ontario. It's about 1.5 minutes, this clip, and it's fairly static, but I chose that for a reason. If we look at, for example, the top row, you can see sky and stalks of grass. In the middle, the texture is different. It's interrupted by orange. So what if we took a slice, the top and in the middle? What might we discover about how this video evolves over time? We could try it out. So I'm going to paste into my command line a command that will convert this butterfly clip into a JPEG. I happen to be navigated to the right folder where this clip lives. And let's see, if I run this command, what do I get? So FFmpeg is now taking all of these frames, it's cropping them to a 1 pixel by 1920 sliver. And then it's tiling them all back together. All the frames of the video tiled back together. So the elegance of that is that we can do it in one command. So let's see what it looks like. This is the top row. We saw sky, we saw blades of grass. What is this wobble? This is my camera shake. So in art history, painters who were trying to conceal their humanity would hide the hand, and the shaking of the brush was a problem to eliminate. But if you were Picasso or someone with an impressionist angle, or if you just liked throwing paint at the canvas, you might have more of a celebration of the hand, of the impasto, of the texture of painting. I started to think that camera shake might be a valuable thing rather than a problem, something to celebrate, something to explore further. We can offset the location of our sampling now. If instead of the sky, I want to see the orange butterfly, I could do the same thing, but I would need to sample a different part of the image. We're going to have the same command, but slightly different. Notice that the crop here is 500 pixels in from the top. That's around where the butterfly is. So FFmpeg does the same thing, slicing the video, but at a different location. This time, we have the same movement, the same texture of the hand, but we've sampled also that orange of the butterfly and also that semi-translucent white of the cocoon from which that butterfly emerged. So this is now a brushstroke that is citing from the source of that butterfly's life. I imagine this might be a nice component for a painting at some point in the future. So let's see if we can get there. We saw that manually I could give FFmpeg these instructions to slice videos. It would be tedious to do that for every row. So can we automate this process? How can we get our tools to behave efficiently? Could we do a slice like this for every 1,080 rows in that video and animate them? Well, we could do it. We would then approach something like our brain scan before, right? We're going to do what we just did, but 1,000 times. How do we do this? We need some method to orchestrate the process. FFmpeg on its own will take those commands and do its thing. But together with Node, I now have a choral conductor who can say, now you do this and you do that, and let's work together, and now we have slices from every single row. Imagine this as an array of instructions that are followed by FFmpeg. Maybe in sequence, or maybe in parallel. Then we could put all the pieces back together at the end. So with FFmpeg and Node.js, we could go further. We could automate multiple slices and reassemble them. Node.js has the ability to spawn children or child processes. So if you've done any scripting, you might run into limits. Node.js doesn't do video very well. It does it, but not efficiently. So maybe we should get Node to outsource the problem to a tool that's better suited to the job. So we have something like this. Now I have hundreds of these, and we can slice that video much more quickly, leveraging the power of the multiple cores in my CPU, right? How many cores are there in your CPU? This is a gaming laptop, so I've got a bunch of them. I don't actually know. Maybe there's 8, maybe more, maybe 12, maybe 4. Not 100 though. So I have a ceiling here still. If I want to do this locally, it might still take a long time to render all of this stuff. So I'm partway there. I found a way to scale up the process, but I've reached what we would call a bottleneck. My CPU can only do so many things at once, right? So this is a toll highway in Beijing, 2016, where there are many lanes of traffic forced into this bottleneck, right? So this is what's happening now with Node and FFmpeg here on my laptop. I reached this point. So how do we open up again this highway? Maybe we need a better transit system. What if we had 1,000 computers at our disposal? Or even just 2. If we work together, you do this half, I do this half, and we'll pool the results. But 1,000, that would really be nice. Where do I find 1,000 computers? In the cloud, right? What we in Dutch would say, the wolk, cloud, that nebulous place where all those computers are purported to live. How are we going to get up there into the cloud? It seems so out of reach, difficult, a lot of big learning curve. So we're going to need one of these, a flying machine, so that when we get to the cloud, we can be productive there. So this is not the Wright brothers plane. This was made by Alberto Santos Dumont. So if you ask any Brazilian, like my partner, she'll tell you it wasn't the Americans who invented the airplane. So you can research that if you like. We will need to build some kind of airplane if we want to leverage those 1,000 computers in the cloud so we can process videos quickly. So what is it like to use cloud tools to make things? You've got options. You could go with Microsoft. You could go with Google. You could go with AWS. I happened to be playing with this at the time when this problem occurred to me. So it's a bit arbitrary that I chose this particular cloud. There are lots of them. On AWS, we have 3 important elements that will be useful to us. The first one is a bucket. Who needs a hard drive when you have a bucket? You can store things in it, carry them around. It's reliable, efficient, simple. So I'm going to put my videos in a bucket, and I'm also going to put the results there too. the slices that I make are also going to end up in an S3 bucket. It's not enough to have storage. You also need a computer, the CPU, the brains. So that's Lambda. On AWS, you can write your JavaScript or your Python or any language that's supported and run it in a Lambda function. This function is orchestrated on our behalf. We don't need to configure any computers. I don't need a laptop to run it. It's not my problem anymore. Amazon will take care of the computers that I need. All I need to worry about is writing my code. So how much RAM do you have in your laptop? 8 gigs? 16? A Lambda function has 10 gigs of RAM. But what if you have 1,000 Lambda function? That's 10,000 gigs of RAM. That's a lot of RAM. That's a lot of memory. So we could maybe go further, do things more quickly. The final element is called step functions. How will we tell those functions what to do? We need some tool to orchestrate the big picture. So you could think about it like a conductor. Step functions is the workflow at a large scale. The lambdas are going like the worker bees to gather honey and do their job. But someone needs to choreograph, orchestrate, you do this, wait until this is done, and then you do that. And at the end, we'll all do this together, and we'll have something like music. That's a violin, it's not a mandolin, but you see the analogy. So for our particular problem, Amazon solves it something like this. I upload a video. I have this step function to orchestrate the tasks that need to be done. I have lambdas that do the tasks, mostly slicing veggies or slicing videos, if you will. Then we have bucket to store the outcome. In my case, I have an Amazon account, and it's full of these videos that I've been uploading. When I upload a video, my step function is listening for that. Oh, you uploaded a video. Let me get to work. Automated, right? It's a pipeline. This is really nice. If you're making a painting, you have a system as well. You have a place to clean your brushes. You kind of get into a groove. You know what you're doing. You don't have to click extra things. So my bucket's getting pretty full. Amazon has a drag and drop tool for building workflows. This is really nice. If you're used to code being a text-only thing, this makes it really visual. So I can drag in the things that I want to do, the sequence in which I want to do them. If I need to make a loop like this, so for each of those video clips, slice them up. AWS allows for this visual way of coding. So imagine we go for a walk through the woods. I upload this to my bucket. Amazon spits out not one, but many slices. And this is now a journey through the woods. I get weird looks when I point my camera up to the treetops, walking around, my arm up in the air, but I don't care. It's worth it. When you're walking through the woods, you might trip on a rock or who knows what happens. Very human thing to do. The trail isn't exactly even, and that's what I want to celebrate here along with the fall colors of Ontario. I don't get to do this every day, so an ordinary day looks a bit more like this. Stuck in traffic, or the traffic is stop and go, and the stop and go-ness of the traffic is represented here by the way that this gray car has a stretched out hood. There's something happening there, you can tell, and that's what it is. It's stop and go. We're moving slow, we're moving fast. If you go to the beach, there's wave action happening, but I'm also performing a wave action by wobbling along the beach like this. So I'm having this conversation with Lake Huron at the Pinery. Okay, so we have these slices. Now, imagine with me a platter of vegetables or fruits or whatever. Can we take those slices and reassemble them now in a new way? Yes, we can do that. We have now not only sliced up our video, we've also reassembled those frames into something new. The logic of this is open-ended. There are many ways to reassemble those frames, just like there's many ways to make a veggie platter. So this has been a productive exploration for me recently to ask what kinds of veggie platters could I make out of these video slices. So a particularly productive one has been to make loops that zigzag through all the available frames. It's a basic way to sort of navigate the entire duration and have it fit, as with our spirals initially, into one 16:9 proportion. If we wanted to see, for example, the treetop walk in this sampled form, the entire thing has become somewhat liquid. The time and space axes have entirely been swapped, but we can't see that for the whole length of video at once. So we have to zigzag our way through it and crop all of those long panoramas strategically so that we have, as a result, that entire journey, each frame now from a slightly different angle, the same moment. So if you take out your phone, the camera sees from different angles the same thing at different times, and that's the wobble then that we can capture. If I start animating the journey like this, those brush strokes start to come to life. So I have this idea that I could paint on a canvas with this texture and have the brushstrokes continue to vibrate the way they're doing here. If we do this with the Snowpiles image, things look a little different. Here, I'm driving in my car. I'm not wobbling the same way. I introduced the wobble afterwards in post. So we have this ethereal kind of fluid motion because a Toyota Prius doesn't walk on two legs. It rolls. But you do see here the zigzag that I introduced afterwards, panning from one angle to another. You see also the background moving at a rate that's unusual, and it might warp your brain a bit to figure out what that means. What exactly does that say about how time is flowing? Similarly, if we're in traffic, what do we notice? The eastbound and westbound lanes appear to be going in the same direction. What direction is that? It's the future. So it matters not if you're going east or west. We're all going to the same place, and that's tomorrow. So we may get there at a different time, and we may, in the process, feel a little stretched or a little thin. I think that highlights a bit of what it's like to be a human on this planet. Having liquefied also the image from the Pinery, it gave me an appreciation also about water and the fluidity of water and how my body is a fluid thing too, as it finds its way along the beach. So maybe we want to try this ourselves. Do you have a video that you would like to slice up? Do you want to send a video to my Google Photos album? You can use this URL to do it. And maybe we can pick one. I'm going to log into my Amazon account in the meantime, and let's see what we can do together. We have videos. This looks interesting. Is this a car wash? Is it okay if I used your car wash video? Okay, thank you for submitting that. So I've got your car wash video here, and I've just renamed it to carwash.mp4. And we're going to drag this into our Amazon video processor now, and let's see what happens. So I have a bucket. This is a bucket on AWS, and it has an upload button. See, here it is. So I'm going to just drag your car wash into my bucket, like so, and upload it. So this will depend on your internet speed, and it's done. What happens now? Remember, my step functions are listening for this. So if I open my video Mandolin now, it says running. That's a good sign. It's running. This is my Mandolin in the cloud. It's chopping up our video into pieces. It does so by first chopping it into clips. If we split a cucumber into chunks and we ask each of you to slice the chunk, we will have slices much more quickly. So the same applies here. If I chop a video into clips, this can be done quickly. A video has keyframes that are natural division points. So I can chop up that video without having to re-encode it. Then for each of those clips, I merge together again the outcome. And now we combine those frames again into a cross-section and generate a video from all of those many cross-sections. So as this is happening, Amazon is spawning many, many Lambdas, up to 1,000 of them at once. And it's done. See how quick that was. So the output of this tells me that I've finished processing this video. So we can now go and locate it in my other bucket, the output buckets. Here we go, sample loops. There it is, car wash. Let's download the result and see what we're dealing with. So that's fun. It's a quick way to iterate now. I don't have to wait 6 years to do a car wash experiment. I can do it in 30 seconds or less. So my discovery there was, it took me a long time to learn Amazon cloud computing, but it was worth it. Imagine all the time I'm saving in my creative practice now. So if you have a tool that automates something in your creative process, it might be worth spending the energy to just explore it and see where it takes you. So I'll send you this video afterwards and you can post it somewhere if you like. And then you can loop your brain around it and see, what does it mean? What does it tell me about the nature of a car wash and the way we flow through it? So if I take that full circle now, what happens? I bring those loops back into Photoshop, and I haven't done this in the cloud yet. This might be a future project. But it's possible to bring all those results back into Photoshop and animate this journey now. So the spiral isn't just a flat, static segment of my journey. It shows it from different angles. It shows it swaying back and forth. So I think there's potential there to iterate further. I might like to paint any kind of shape, not just a spiral based on a fixed procedural algorithm, but any kind of vector shape that you have in mind. Could be the target for mapping video texture. That hasn't happened yet. It might happen in the future. I'm going to need to continue iterating along these Mandolin tools. And I learned some things along the way there, also from RuPaul. You better work. And maybe art practice is that kind of industry where you find an ethic or a practice or a habit. Sometimes it involves spending. If you make mistakes on Amazon, you pay for it through the nose. If you find a solution to a problem, you'll also pay, but you'll pay a lot less. So the good days are the ones where I coded it properly. And the big leaps are, I spent too much money because I coded it wrong. You're going to need that kind of a commitment to a creative practice to get anywhere. That's just the reality of it. A lot of this involves math. So if you don't understand the math, draw a picture of it until you do, because it's really just about relationships. And maybe you can code a little slider so you can start to grok how a sine wave actually behaves. So this took me like several months, and I had to put the whole thing on pause before I understood the math well enough to proceed. So you have to be okay with taking a few months to do something else. You can also chat with robots. They'll give you advice on things like, how can I split a video with FFmpeg? And ChatGPT will say, do this. You don't have to understand it for it to work. But watch out, because the advice might be wrong. It's using an outdated version of the docs. So that actually didn't work. Even though it's coherent, it's outdated. I'm sure that they fixed it in GPT-4. Chat with humans as well. I have a cousin who's a scientist, and he was telling me that I should use NumPy, which is a Python library, and you can use Python on Lambda. So it's a possibility. And I might come back to this in the future. It does work, but I haven't optimized it yet. Document everything you do. This is a giant Miro board, not only modeling the structure, the architecture of the project, but also what I learned from it. So it's a spidering out of many links and resources and finding my way around a complex terrain. Read about best practices. What's the best way to do this? What did other people do? Enjoy the error messages. They are your friends. They tell you what to do next. Other people have the same ones, so you can research what's going on when I get this error. It's problem solving, and it's a really delightful thing to enjoy. So enjoy the errors. You need a focused state of mind. So I have to tune out RuPaul's Drag Race so that I can finish this problem that I have a focused space for. This is my hack. I have the opportunity to sit on the couch and enjoy a Netflix and chill with my partner, but I'm also getting something done because that's my creative time. So I put on the white noise or the rain on the lake, and I can be present, but also focused. If you have a complicated problem, try to break it down into chunks. If you tackle one small chunk, it'll feel like a success. And then it turns out that the bigger solution reveals itself after a while. It's also fine to hide. It may not be your experience, but it has been mine. Carving out time to be creative is important. As I said, it's my goal to map video texture onto any shape. And there are tools on my GitHub you can check out that begin to make this possible. So I've been learning from Illustrator. How does Illustrator map texture onto a path? And how do you go around complicated corners? The math is not simple. So I'm learning about GPUs. The GPU has solved this problem elegantly already. And we have GPUs in the cloud. So I'm curious from here, how can I use things like frame interpolation to stretch the time even further? Your video might be 60 frames a second. Can we make it 240 and zoom into the details? I'm exploring WebAssembly so that we can warp images in the browser without having to use JavaScript. JavaScript can do this, but it takes forever. But with WebAssembly, we can use native code. We can use a C program. We can use anything to manipulate imagery in the web browser. I'm going to have to leave it there because we're out of time. And I don't know if that link works, but it might.